Okay, so today we're going to be looking at this problem. Given a sequence a sub n with a sub 1 is equal to 3, and a sub n plus 1 over n is equal to a sub n over n plus 1 over n times the quantity n plus 1, we have to prove that the sequence n times a sub n is an arithmetic progression. So basically, what that means is that if we found a general formula, or not a general formula, but a recursive formula for a sub n plus 1, or I guess n plus 1 times a sub n plus 1, so n plus 1 times a sub n plus 1, actually, wait, backtrack, so, let me just restart this. Okay, everybody, welcome back. Today we're going to be taking a look at this problem. Given a sequence, a sub n, with a sub 1 equals 3, and a sub n plus 1 equals n, or over n, equals a sub n over n plus 1 over n times the quantity n plus 1, we have to prove that the sequence n times a sub n is an arithmetic progression. So the first thing we're going to do is we're going to simplify this equation a little bit. I'm multiplying both sides by n times n plus 1. So what that's going to give us is n plus 1, a sub n plus 1, equals n a sub n plus 1. And believe it or not, we're basically done already. The next thing we're going to do is we're going to take a look here. N plus 1 times, actually, if we replace n a sub n with any term, let's call it b sub n, then n plus 1, a sub n plus 1, is going to equal b sub n plus 1, because we're just increasing all of the n's here by 1. And so what that's going to give us is b sub n plus 1 equals b sub n plus 1. And this is already in the form of a recursive formula for an arithmetic progression. So that tells us that b sub n is an arithmetic progression. With common difference of 1. And since b sub n is just n times a sub n, then n sub a plus n sub a sub n times a sub n equals b of n. So it is an arithmetic progression. Not an incredibly rigorous proof, but it does show that this is the case. And so that concludes this problem.